Hello people, welcome to the first episode of our grade 10 IGCSE video. Today's topic is about rotten egg. So how long does it take for an egg to go rotten? A day? 2 days? Or a week? Or even a year? Well, you're going to find that out after we finish this lesson. So the title of this is the rates of an reaction. We want to know what is rates of chemical reaction. We want to be able to understand how do we measure the rate of chemical reaction. And also, we want to know how can we change the rate of chemical reaction. Here's our first exercise. It's called fast and slow. Let's rank them. You have 4 different types of activities that you need to rank according to how fast they take for this activity to be processed. So first thing is you have raw egg turning into hard-boiled egg. And the second one is fruit going rotten. Okay, how long does that take? And baking bread or rust form on the car. So rank them according to how fast they are. Okay, let's make it precise. Most of the time, we can say something, oh, this process is very slow or it's very fast to boil an egg. But sometimes we want to use terminology to help the other people understand how fast, exactly how fast or exactly how slow something takes. Rate. So we're using the terminology called the rate. It is how much something changes over time. So here are a few examples. Firstly, the speed of a plane is 800 kilometers per hour. Okay, so the change over here is 800 kilometers is the length that it flew away, and the time over here is hour. So you can see that we're using single unit of time. So per hour, in 1 hour, this plane will fly for 800 kilometers. The next one we have is petrol pump. So here we have it is 50 liters per minute, which means that in 1 minute, it can pump in 50 liters of gas. Okay, the next part is I can eat 2 bowls of ramen per hour, which means that in 1 single unit, which is an hour, I can eat 2 bowls of ramen. Okay, the time we have second, minute, an hour, and a year. So here we have the rate of chemical reaction. So in specifically, we have zinc react with sulfuric acid and produce zinc sulfate and hydrogen. So in here, we have zinc and sulfuric acid being our reactant, and the zinc sulfate and hydrogen being our product. Okay? So to write the word equation into our chemical equation, the zinc goes into zinc, and S, it means solid. Sulfuric acid, we write it as H2SO4, and AQ means that it's in water, so aquarium. And the next one's zinc sulfate, which is ZnSO4, hydrogen H2, and G means it is a gas. So what are the changes in this chemical reaction? Think that for a second. What are the changes? What are being produced? What are being used? So we have zinc and sulfuric acid are going less because they're being used. And zinc sulfate and hydrogen, there we have more of them, right? So those are the changes we can have in this reaction. We can say in this experiment, theoretically, we can figure out the amount of zinc being used per minute as our rate, or the amount of sulfuric acid used up per minute as our rate. Or we can measure the amount of zinc sulfate, which is this one, being produced per minute, or the amount of hydrogen being produced per minute. Okay, all of these 4, theoretically, they're all fine. So you have finding the rate of chemical reaction. So you can either measure the amount of reactant being used over time, or you can measure the amount of product being produced over time. Firstly, how do we measure this? It's kind of hard to figure that out, isn't it? What about this experiment specifically? Zinc and sulfuric acid produce these 2. And we will sometimes have some leftover of zinc. So it's kind of hard to figure out, which ones are the zinc, which one are zinc sulfate, because they're all mixed up. And the only one thing that is kind of easy for us to measure is hydrogen, because it's a kind of gas. We can just collect the amount of gas that has been produced in the experiment and then figure it out. Okay, so it's easier to measure the gas. In this case, it's hydrogen. Let's go to that experiment. We will have a flask and our reaction mixture. We will use a gas syringe to measure the amount of gas that's being produced in this experiment. And also we will need time, right? Because the rate, remember, is a change over time. So we need to have our stopwatch to measure the time. So firstly, we need to clean magnesium with sandpaper, because often the time magnesium has been coated with magnesium oxide, which makes it harder for magnesium to react. So we need to clean the magnesium sulfide out with sandpaper. And then we're going to draw magnesium. And then immediately we're going to insert the stopper, which is this one over here, and syringe, because we don't want any gas escape. And then we're going to start clock at the very same time. Okay, here are the results for the experiment. So you can see that on this part is time, which is in here we're using the unit of minutes. And also we're measuring the volume of hydrogen. So you can see the unit is cubic centimeter. You can see at 0 minute, there's nothing being produced, right? And at half a minute, we have 8 cubic centimeters of hydrogen being produced. And it's going more and more and more as the time goes through. And in here, the volume of hydrogen is not increasing, right? It just remains 40 cubic centimeter. So when does it stop react? You can say that at 5 minutes, it stopped react because there's no more hydrogen being produced. How many hydrogen being produced in total? So we look at the 5 minutes, and in total, the maximum amount of hydrogen is our 40 cubic centimeter, right? If we plot all these data into a graph, our x-axis is going to be our time, unit is minute, y-axis being our volume of hydrogen. So we plot the graph. Okay, so we simplify the graph by drawing like this. Okay, it's the same kind of form. And we basically choose some dots. We draw the slope at that part of the dot. Basically, the change over time is our slope. The steepest it is, it goes faster. The slope is bigger, right? So here in this, you can see it's the steepest over here, and then it goes less steep, and then this goes less steep, and here it turns flat, which means that the reaction is over. So in here, when it's fastest, the curve is the steepest. And when it's slower, it goes less steep. How to measure the average rate of the reaction? Remember, the rate is change over time. In here, the change is our volume of hydrogen. And the time in here is minute. So you want to have the total volume of hydrogen, which is 40 cubic centimeter, over total time of this reaction, which is 5 minutes. We're not going to use 7 minutes because the reaction basically stops after 5 minutes. So we have 40 over 5, that gives you 8 cubic centimeter of hydrogen per minute. Remember, the rate is change over time. So that was the rate of a chemical reaction. How can we change the rate of some chemical reaction? Sometimes we don't want it to react that fast. Sometimes we want to make it slowly, or sometimes we just want to go fast as it could, right? So here are a few methods for us to change the chemical reaction, the rate of the chemical reaction. Firstly, we can change the concentration. So a reaction can go faster when the concentration of a reactant is increasing, or it's more, right? Experiment A, I'm putting 0.05 grams of magnesium, and I'm putting 50 cubic centimeter of hydrochloric acid. And in experiment B, I'm putting the same amount of magnesium, 0.05 gram, and I'm adding the same volume of the hydrochloric acid, but I make it twice as concentrated. So if in here, if it is 1 mole per liter, in experiment B, I'm going to make it 2 moles per liter. Okay, make it twice as concentrated compared to experiment A. So here's the graph that we got. Experiment A, experiment B. The A is the one that has less concentration over here, and B is the one that has more concentration. The more steep the slope is, the faster the reaction gets. So in here, obviously, the reaction B, the curve is steeper, therefore this reaction is faster. How come they all have the same amount of hydrogen? Well, if you go back to this reaction, you can see that they are using the same amount of magnesium, right? If I don't put food in the fridge, what's going to happen to them if I leave it outside? Well, most of the time it's going to go rotten, right? So putting the fridge basically decreases the temperature, which means that if I decrease the temperature, then the reaction gets slower. So on the other hand, the reaction gets faster when the temperature increases, right? If I take the food out of the fridge, they're going to go rotten. They're going to react with the bacteria faster than they have. So changing the temperature is another way to change the rate of an reaction. It won't change the amount of product being produced, but they will change the rate. Same as changing the concentration. You will not change the amount of product being produced. I will not get more hydrogen if I only have more hydrochloric acid, right? But I'm changing the rate. I'm changing how fast it gets. In this reaction, I'm putting larger chips of one of the reactant, and in here, I'm kind of grinding up one of the reactant, making into a smaller amount of chunks. So I'm changing the surface area. So a reaction will go faster when the surface area of a solid reactant increases. So if I'm making into powder, it's going to go even faster, right? That's it for today's video. Thank you guys very much, and see you next time.